Okay, so the data given there in the problem is lambda 1 is 0.008 PGY, PG1 plus 8, and lambda 2 is 0.0096. Now, normally, all right, they assume both units are operating all the time. The total load varies from 250 to 1,250 megawatt. Maximum and minimum loads on each unit is 625 and 100 megawatt respectively. Find the incremental fuel cost for the plant and the allocation of loads for units for minimum cost and various total loads. Now, all right, this at light loads, unit 1 will have the higher incremental fuel cost and operates at its lower limit of 100 megawatt. So therefore, DFI is 8.8 Rand per megawatt. When the output of unit 2 is also at 100 megawatt, then DFGD is 7 Rand 36 per megawatt. So as the plant output increase, the additional load should come from 2 until DF2 PG2 is 8.8. Until this point is reached, the incremental fuel cost lambda of the plant is determined by unit 2 alone. So when the plant is 250 megawatt, unit 2 will supply 150. So with that, DFPG is 784 and DF2 is 8.8. So there we've got those equations. And now let's take for B to be 500 megawatt. All right, let me just swap this. So now we have to determine PG1 and PG2. Now let's just look at the example there. So 1 over alpha 1 plus 1 over alpha 2. So alpha is the number before PG, and that is 1 over 0.008 and 1 over 0.0096. Get the inverse of that. That gives you 4.364 times 10 minus 3. And beta total is alpha times B1 over alpha 1, B2 over alpha 2. So that's 4.364 times 8 divided by 0.008 and 6.4 divided by 0.0096, which gives us 727.3. Then for each unit, lambda is alpha T PGT plus BT. So that means it's 4.364 times 500, because we want to know what it is at 500 megawatt, plus that 7.27, that gives us 9.455 rands per megawatt. So now we're going to look at how much is PG1 going to supply and plant 2. So that will be lambda minus alpha divided by 0.008. That gives us 181.812 megawatt. And PG2 is the same, 9455 minus 6.4 divided by 0.00196. And that gives us 318.182. So if you sum those two, you will find that it's 500 megawatt. Now what they've done, because they wanted the load to vary from 250 to 1,250, then you're going to calculate lambda for each one, and then 100 megawatt, and so on, 350. And then you can see at 500 volt, things start changing. But unit 2 is always supplying more. So basically, that's all I want you to calculate. It will be something like this, and then determine the load of each one. Any question there? So just go carefully through this, what I've written here, and you'll find that it's not so difficult. And then example 2 is the savings. A total load of 900 megawatt between the two units of the plant in example 1. Compared with equal distribution of the same load, the table shows that unit 1 should supply 400 megawatt and unit 2 500 megawatt. So if each unit supplies 450 megawatts, the increase in cost for unit 1 is from 400 to 450 times F1 dPg watt. And that will be 0.004 Pg squared plus 8 Pg. And then we substitute the values. Then it comes 570 Rand per hour. For the increase in cost, because now it supplied 500, now it's going to supply 400. So that means it's minus 548 Rand per hour. So the net increase in cost is then 570 minus 548. That gives you 22 Rands per hour. Now that seems small, but over a year with 8,706 hours, it becomes 192,720 saving. So if you go back to that, you can see at 500, no 900. It says that one supplies 400 and that one supplies 500. If each one of them supplies 450, that means this one have to increase and that one have to decrease to 450. And that is what we've done there. We've taken the integral of the area 400 to 450 and from 500 to 450. Okay. Okay, this is the examples of the book. So if you can go through that, I think you should be fine. Any other questions?